All right, let's take a look at problem number 9. It says um, David has two jobs. He earns $8 per hour babysitting his neighbor's children, and he earns $11 per hour working at the coffee shop. The first question says that write an inequality to represent the number of hours X babysitting and the number of hours Y working at the coffee shop that David would need to work to earn a minimum of $200. So do you know the equation that relates your pay rate, amount of hours you work, and the amount you earn? Well, there's a formula that can relate all three variables, and I like to call it the ART formula. The ART formula. Okay? So you may wonder, what does the ART formula mean? Well, the ART formula simply means that the amount earned, so amount earned is the pay rate times the time. Okay? Time worked. So that's how you calculate the amount earned. In this case, David has two jobs, so he's going to have two ART formulas. All right. So let's go ahead and generate the two formulas that we're going to be looking at. So we're going to have one for babysitting. So for babysitting, the amount that David is going to earn for babysitting using the ARC formula is the rate for babysitting, which is 8, times the amount of hour that he works. Okay, so he worked X hours babysitting, so it's going to be 8 times X. So this is the amount he earned babysitting. The next job he did is working at a coffee shop. So for the coffee shop, what's the amount he earned? The amount he earned using the ARC formula A is the rate, the pay rate at the coffee shop. How much does he get paid at the coffee shop? $11 per hour. So the rate is 11. How many hours did he work? T is Y. Okay, so it's going to be 11Y. So this is the amount he earned babysitting and the amount he earned at the coffee shop. So you just basically multiply the pay rate times the time in hours to get the total amount he earned. Now the question says that we should write an inequality that represents the total amount he earns. He wants to earn a minimum of $200. So if you think about minimum, think about floor. Okay? What does the word floor call to your mind? Well, floor means you can't go lower, right? You can only be there or higher. Okay, so think about higher as greater. So anytime you think about minimum, we're looking at greater than, yes, greater than or equal to. So that's what minimum basically is. So if he wants to earn a minimum of $200 combined, we're going to combine these two, his total earnings, 8x plus 11y, amount earned babysitting plus amount earned in a coffee shop has to be greater than or equal to 200. This is what it means for the minimum to be $200. The next question says, David worked 15 hours at the coffee shop. Use this inequality to find the number of full hours he must babysit to reach his goal of $200. All right, so if David worked 15 hours at a coffee shop, that means that the amount of hours in the coffee shop is equal to 15. So which variable is for coffee shop? Y is the amount of hours he worked at the coffee shop, right? He did X is for number of hours babysitting, and then Y is number of hours at the coffee shop. So in this problem, we have Y is equal to 15, and we have the other equation from the first part, 8x, amount earned babysitting, plus 11y, amount earned at the coffee shop, must be a minimum of 200. So now that we have y set to 15, what is x going to be so that he can reach his goal? We're going to substitute 15 into this inequality and solve it. So we're going to have 8x plus 11 times 15 is greater than or equal to 200. Alright, so we'll simply solve this inequality for x. So first thing we do, we multiply 11 and 15. That gives us 8x plus 165 is greater than or equal to 200. We subtract 165 from both sides, and that yields, let's break it up. Go right here. We have 8x is greater than or equal to 35. Divide both sides by 8. Divide by 8. Divide by 8. And then we'll have x is greater than or equal to 4.375. Alright, so this is not an exact amount of hours. So the question is, how many hours should he work? Should he work 4 hours or 5 hours? If he works 4 hours, he's not going to earn enough money to meet his goal. So in this case, since he's working in hours, we have to round this up. Okay, so x is equal to 5 hours. This is the hours he must work to guarantee that he meets his earning goal of $200. All right, let's take a look at question number 10. Number 10 states that on the set of axes below, graph the function y equals the absolute value of x plus 1. So, do you recall what the absolute value function looks like? We asked to graph y equals the absolute value of x plus 1. This is the parent x absolute value function translated along the x-axis. If you know what the translation is, you can have an idea of what the graph is going to look like before even you start graphing it. So let's talk about that for a second. We have y equals the absolute value of x. This is your absolute value function. And it is like a v function centered around the origin. So let's make a sketch of what the graph looks like. So the absolute value function, see, looks like this. So this is your y and x-axis. So it's kind of like a v centered at the origin. Now, what if you have x plus 1? What does that cause to happen with the function? If this changes from x to y equals absolute value of x plus 1, this plus 1, we're going to do the opposite. All right, is the movement along the x-axis. Plus 1 means you're going to shift to the left 1 unit. Okay, 1 unit shift to the left. So your resulting graph is going to look like this. Go ahead and draw what that graph looks like. Is 1 unit shifted to the left. So that's what your answer should look like. So this is just a sketch. The v shifted to the left. All right, to make sure that our graph is in fact accurate, what I'm going to do is I'm going to make a table of values. I'm going to use 5 points to generate some output values that we are going to graph. All right. So this is my x, and this is my y equals the absolute value of x plus 1. All right, so I know this is centered around -1, since that's a shift. That's where the v is going to be located. All right, so let's use the 5 points centered around -1. So let's put -1 here, and then -1, let's go up to 0, 1, and then go down -2, -3. All right. So when x is 1, what is y? Y is going to be the absolute value of 1 plus 1. The absolute value of 1 plus 1 is 2, because the absolute value of 2 is 2. When x is 0, we're going to have the absolute value of 0 plus 1. 0 plus 1 is 1. The absolute value of 1 is 1. When x is -1, y is going to be the absolute value of -1 plus 1. -1 plus 1, let's try that again. -1 plus 1 is 0. So let's do -1 plus 1 is 0. Absolute value of 0 is 0. And then -2, absolute value of -2 plus 1 is -1. Absolute value of -1 is 1. And then for y equals -3, absolute value of -3 plus 1 is -2. Absolute value of -2 is 2. Anytime you take the absolute value of any number, you always end up with a positive answer. Okay? So when x is -1, y is 0, the point there. When x is 0, y is 1, 0, 1. When x is 1, y is 2. All right, you see the symmetry there. When x is negative 2, y is 1. When x is negative 3, y is 2. All right, so let's go ahead and connect the dots, and that will be our graph. So this is the situation to the right of negative 1, and then to the left of negative 1, that's what you get, like that. Okay, so this is the equation of the function y equals the absolute value of x plus 1. You notice that we even knew what the answer was before ever we did any work. That is because we had an idea of what the parent function looks like, AV, and this plus 1 basically means a shift 1 unit to the left. That's what we discussed here. So you see how this vertex V right here shifted 1 unit to the left to negative 1. And then just using a few points, we have the graph of our function, all right? So that's that. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to our channel for the rest of this review series. More clips can be found on math.serve.com/testprep. Thanks again for watching and have a wonderful day.